Okay, so this second little video is just going to talk about electron arrangements. So for the moment we're not going to worry about what's going on in the nucleus. All we're going to worry about is our electrons. Okay, so we're just going to think about the electrons for now. So for the moment we're just going to think about our nucleus in the middle here, which is full of protons and neutrons, but we're not going to worry too much about those for the moment. Okay, so we'll start with a nice easy element. We'll start with lithium. Okay, now with lithium, if we have a look on our periodic table and we look for lithium and we see the numbers that we've got for lithium, we have got 3 and 7. Okay, so if we think about those electrons, we've said that they float around the outside of our atom, okay, in various patterns. Now our 3 here, which is our atomic number, tells us how many electrons we have. Okay, so the small number, remember, always the number of electrons. So if we think about these electrons, we need to have 3 of them in total. Here's our 3 electrons. Okay. Now there's rules about how many electrons we can have in each shell. Okay, so these are called shells here. Now our first shell can only have 2 electrons in, so we put our 2 electrons here. Okay, so shell 1 has a maximum of 2 electrons. So our third one here that we've got left over is going to have to go in our second shell here. Now shell 2 can have a maximum of 8 electrons until we say it's full. We can, for bigger atoms, okay, remember we're only going up to 20 in the periodic table, have shell 3. Now shell 3 can strictly have a maximum of 18 electrons in it, although with our third row what happens is they tend to go up to a maximum of 8 before they start filling in their fourth shell, and if you do chemistry further up school you will learn exactly why that tends to happen with some of our elements. Okay, but for us in year 9 we're going to think 2, 8, 8, okay, for the 2 shells. Now sometimes you'll be asked to write down what's called the electron arrangement. Okay, so by the time we get up to much bigger atoms it's quite difficult to keep drawing this out to describe what's happening. So if we want to draw the electron arrangement or write the electron arrangement, we look at how many electrons we've got in the first shell, which is 2, and then we draw a full stop, and then we count the electrons in the second shell. So here we've got 1. So the electron arrangement for lithium is 2.1. Okay, so 2 electrons in the first shell and 1 in the second shell. Okay. Now the further up the periodic table we go, the more shells we might have to deal with. So the next one we're going to look at is sodium. So if you have a look on your periodic table for sodium, if you can't quite remember this, we've got 11 electrons this time. Okay, for sodium. I'll just redraw that a little bit better. Okay, so for this one we've got to think, how are we going to get all these 11 electrons into this particular pattern? Okay. Now, same rules apply. We can still only have 2 on the first one. We use my smiley faces now. But this time we've got 11 in total to fit in. So we need to put some more on the second shell, and we can have a total of 8 on the second shell. So we can manage to squeeze 8 on there. Need a bigger board. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 in total now, but we need 11 because our atomic number is 11. So this time we'll have to include that third shell around the outside here, and we will need to put 1 on that third shell. Okay, so now if we count them all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Is that right? I've got too many now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, that's right. Okay, so if we wanted to write the electron arrangement of this one, we would have 2 on the first shell, 8 on the second shell, and we'd have 1 left over for the last shell. Okay, so for lithium, 2, 8, 1. Okay, and that hopefully all adds up to 11, which is what we need. Now what you'll notice is that if we look back on our periodic table, we'll see that lithium, okay, which remember when we wrote its electron arrangement was 2.1 for lithium. Both lithium and sodium are in group 1. So it's kind of a clue that if you look on your periodic table and you're in group 1, that you're going to end your electron arrangement with a 1. Okay, we call these electrons on the outside shell valence electrons. Okay, so these are your valence electrons. So this one here that's on the outside shell, we call it a valence electron. And what this means is anything in group 1, because it only has 1 electron on the outside shell, it's always trying to lose that 1 electron. That means that that outside shell would then be full again. If we lost that third shell, we'd have a second shell that was completely full. Okay, so anything that's in group 1 has very similar chemical composition, very similar chemical properties. It means actually that these ones in group 1 are very, very reactive. And if you think back to class, we watched those little videos, and you've probably seen it as a practical as well, where you throw sodium into a bath of water, and we get quite a violent reaction where we get flames and possibly a little tiny explosion. Okay, so anything in group 1 will always have a 1 on the end of its electron arrangement. And if you look at page 8 on your notes, it goes through those things for you. So you should be able to practice the ones further up the table. Okay, so if we think about our groups, anything in group 8 or 18, okay, on the periodic table, however you've labelled it, will have 8 in the last shell. Anything in group 7 or 17 will have a 7. Anything in group 6, 16 will have 6 in the final shell. Okay, so it helps to show us how in the periodic table, and if we just have a quick look at the periodic table, there it is. Okay, why these things are arranged in these different groups. So group 1, they've got 1 on the outside shell. Group 2, they've all got 2 on the outside shell. And then we pop over here to where we've got boron. Group 3, 3 on the outside shell. Group 4, 4 on the outside shell. 5, 6, 7, and then 8, where our final shell is completely full. So if you've ever wondered why the periodic table is grouped the way it is, we've got the groups tell us how many are in the final shell, and basically the rows across tell us how many shells that is in. Anything on this will have 2 shells with varying amounts of electrons in. Anything on the third row will have 3 shells. Okay, and then on the fourth row 4 shells, but we don't really go too far into the fourth row. So hopefully that helps you to understand a little bit about electron arrangements, but also about why the periodic table is arranged the way it is. And in the next little video, we'll start to look at compounds and how compounds are affected by this arrangement of electrons.